right, at this point we start our very last chapter of t-tests. Chapter 9, we had a single sample t-test, one sample measured one time. Last chapter, chapter 10, we had independent measures t-test, two separate samples measured once each, and each sample representing a different population. Today, we're doing a repeated measures t-test. This is one sample measured twice, repeatedly. So we're going to find that because it's one sample, most of the formulas look pretty much identical to the formulas from chapter 9. They all look pretty similar. But that's what we are working on here, is repeated measures t-test. One sample measured twice, typically before a treatment and after a treatment. This design has a number of advantages over the independent measures design that we talked about in the last chapter. Has some disadvantages as well. We'll have that towards the very end of the chapter today. But one of the things you're going to hear me talk about quite a bit is the term called individual differences. Let's think about what we were doing in the previous chapter. We got two different samples from two different populations. We measured sample A once, we measured sample B once, and then we compared them to say, hey, are they significantly different from each other or not? Well, if they were, we concluded that whatever the treatment was is what made them significantly different, or most likely that's what caused it. But notice a really big alternative explanation here is that maybe the groups were scored differently because they're different, because they're different people in each group. Maybe I'm comparing apples and oranges here. Maybe the differences across the individuals is what's causing the differences in my measurements. So let's say I was doing an independent measure study and I was comparing males versus females on some task. Well, maybe if there's a difference at the end, maybe it means that males are different than females at that task. Or maybe it just means this sample of males just happens to be different than that sample of females, that really men and women aren't different at all. Maybe it's something with the samples. So individual differences is that, as far as the differences we see in our data, due to comparing strangers, due to comparing individuals against each other. Sample A compared to sample B, I'm comparing strangers to strangers. In a repeated measures t-test, I'm comparing people to themselves. This is what you were like before the treatment. This is what you scored as after the treatment. I'm not comparing you to a different human being. That is going to reduce a tremendous amount of error in our studies because we can get rid of these individual differences this way. They're not going to impact our study at all. So the main difference between this t-test and any other t-test we've done or the z-test we started with is that in this t-test we are not really going to be concerned about the raw scores. Every individual person is going to have two raw scores, the raw score for the first measurement and the raw score for the second measurement, or what we would call treatment condition 1 and treatment condition 2. So every individual person gets two raw scores. But what I want to know is, are those scores different from each other? So here's the thing you're going to hear 500,000 times across this next set of videos. In repeated measures t-tests, I'm not working with the raw scores. I'm working with the difference scores. The difference between their first raw score and their second raw score. Once I've determined that difference, I never use the raw scores again. So the raw scores just get us to things called difference scores. Now, for this type of test, and this is going to become common for most of the rest of the chapter, there's essentially some prep work we should do before we even start talking about the four different steps. We'll get to our 4 steps in just a second here. But first we've got to do a little prep work. A preparation stage is going to be an absolute piece of the process for really all the remaining chapters. So the first thing that we need to get are the difference scores. You get difference scores by subtracting the two raw scores. Their second raw score minus their first raw score. It's a lot like a deviation score that we've used in a couple other chapters. Similarly, it's important that we subtract in the correct order. Second measurement minus the first measurement. This way, if our difference score is positive, it means the second measurement value went up. And if the difference score is negative, it means the second difference score went down. If we flip that around, we'll get our signs backwards. So every individual person gets two raw scores, but they only get one difference score. So we take both of their raw scores and subtract them out to get them one difference score. And as I said a moment ago, once we've got their difference scores, we don't care about the raw scores again for the rest of the test. Second thing we need to know is the mean of those difference scores. Now, your authors, don't put that little subscript of a D for different scores everywhere. I'm going to put it everywhere today because it's really important you keep that straight. This isn't a mean or an average of the raw scores. This is the mean or average of the difference scores. It's still an average. How do you get an average? Add up the values you've got, divide by the number of values. So to get the average difference score, we would need to sum up the different scores and divide by the number of different scores we've got. So first we get the different scores, then we get the mean of those different scores. Some problems might give that to you. If they don't, it's something you've got to get prepared first. And the last thing we need before we really go through is our sums of squares. But remember, this would be our sums of squares, sum of squared deviation scores. We're not looking at deviation scores. We're looking at the sums of squares of difference scores. It's the same formula that we have for sums of squares that we've had ever since chapter 4. It's an old formula for us now. We're just going to put in the symbol D for difference scores instead of the symbol X for raw scores. So we would need to get the sums of squares for our difference scores. So these are three things just to make sure you've got done for any of these hypothesis tests. It makes step 3 go much more smoothly. So we can just go bang, 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 plug and play into our formulas and be done. So by getting these ducks in a row, if you will, first, it makes us set up for success for our steps. So in the next step, we'll start walking through our 4 steps like we always do, generically first, and then we'll explore a problem together.